Hi, I'm JB Baker, the VP of Products and Marketing here at ScaleFlux. ScaleFlux is a leader in developing innovative technologies and products that connect data with compute to address the challenges of building a modern, sustainable enterprise data center. The first technology we've developed is a SoC ASIC specifically for computational storage drives. Now, what is computational storage? Computational storage is moving some compute tasks down into the storage. So in this case, what we've done is integrate extra compute functionality right into this SoC ASIC that sits within a computational storage drive. So adding this functionality directly into the chip and sitting it in the drive represents an advancement in NVMe SSDs to enhance overall system level performance and drive functionality. All of this is going to result in better application performance, better drive endurance, better drive reliability, better scalability for your applications, and better overall TCO. We're seeing our customers deploy these computational storage drives in mission-critical applications spanning from AI applications, high-performance databases, hybrid transactional analytical processes, as well as for edge computing deployments. At the heart of our 3000 series of products is the SFX 3000 system-on-chip ASIC. In this generation, what we've done is leverage the core architectures that we had developed in the 1000, 2000 generations, put them all into a single chip ASIC for improved performance, power, and board space. In this ASIC, we have four key functional blocks: the flash controller, the hardware compute engines, the embedded cores, and the PCIe interface. The flash controller is a 16-channel flash controller to enable maximum parallelism and the high performance that's demanded of today's modern NVMe SSDs. Hardware compute engines is where we've got the magic is happening. In the hardware compute engines, what we're doing is transparent compression and transparent decompression of the data. So as you send data to your drive, this is going to compress the data, and as it's read back, we're going to decompress the data. This is a unique feature for the ScaleFlux controller that you won't find in other NVMe SSD controllers. So putting these hardware compression engines into the drive changes compression from being a burdensome task on the CPU to an easy-to-do task in the drive. Compression is very well suited for being done in a hardware engine, which is a state machine and can perform the same task over and over again very rapidly, as opposed to trying to do this task in software in a general purpose processor, which can bog it down significantly. Paired with the hardware compression engines is an innovative flash translation layer, which is able to take advantage of and manage the varying lengths of data that come out from being compressed. A standard drive is going to have a 4K map. Every chunk of data is going to occupy 4K. After you do compression, your data may come out as 2K, 3K, 5K. So we can track all of those variances and pack them all together to give you the maximum value out of your compression. The next functional block are the embedded cores. We embed two quad-core clusters into the controller. These are there to manage the FTL as well as enable us to do customized functionality. Then the last piece is going to be your PCIe interface. We have a by4 Gen 4 interface there to match performance needs of today's modern servers. So now what's the big deal about the SFX 3000 overall? Well, there's a couple of things here. One is that transparent compression decompression function to enhance efficiency and TCO, all the things I've already talked about. Second is that this uses the in-box NVMe drivers. So it plugs in and operates as you would with any other NVMe SSD controller. There's no new software to install, no application integration to make, no vendor unique things for you to manage in your environment. You just utilize this for your SSD and plug it in as you would an ordinary NVMe SSD.